In this short video, we will demonstrate the Decision Exploration Lab. We will walk through the example which we describe in our paper as well. That is the car insurance eligibility use case. In this use case, we want to compare properties of drivers with the outcome of the decision model, which is in this case eligible, ineligible, or manual. We start our investigation of the decision model with the data space tree on the left side. We first look at the output attribute eligibility. When we inspect the possible values, we find out that only 88.6% of the people is eligible. This comes as a surprise because the rule set was designed to have an acceptance rate of at least 90%. So we want to find out if there is room for improvement, and if so, how we can improve this decision model to reach the desired acceptance rate. We know that the eligibility of an insurance request is mostly determined by the attributes of a driver and not so much by the attributes of a car. Therefore, to start our investigation, we select the eligibility output attribute and all attributes related to drivers. After we selected the desired attributes in the data space tree, we turn to the decision map. The first thing we do is to check the explained variance by the map at this point. We see that horizontally only 47% is explained and vertically 10%, totaling to only 57% of variance, explained variance of the data. Also, when we look at the two contribution plots at the bottom right and top left, we see that both plots have a long tail consisting of attributes that don't contribute to the structure of the data. We can hover the bars in this plot to see where this data is in the map and how much they actually contribute. For example, we see here the driver occupation, which doesn't contribute anything to the first factor, meaning that we can actually remove this attribute from the analysis to simplify the view. We now start to remove the variables which we found in this long tail. Each time we remove a variable, the decision map will be updated with the new selection of attributes. We end up with this new decision map where in total 76% of the variance is explained, and decide that we will base our conclusions on this map. To gain insight in the placement of attribute values, we use the contribution plot. For example, when we click the age attribute in the plot, we can see where the different age values are placed in the map. For example, we see that next to ineligible we find people below 18 and above 80. For the business problem we are trying to solve, we are not so much interested in individual values, but in categories of drivers. Therefore, we start to merge the view until we end up with a number of categories that look suitable for solving our problem. We now have clustered closely correlated values and can inspect the resulting concept islands to see what the categories exist of. We first start with the eligible people by selecting this concept island. On the right, we see a complete description of the values that got merged into this category of drivers. The most important observation is that these are people between 25 and 80, have not been caught for driving under influence, and are no longer a student. These observations meet the expectations of the analyst. At the top, we find the ineligible drivers, which are most closely correlated to people above 80. More to the right, we find people below 18, which are more correlated to driving under influence, but from the rule set we know that people below 18 are not eligible either. At the bottom of this decision map, we find the people who were triggered for manual processing. This leaves us with the students which are centered in the decision map. This leads to the conclusion that students are not strongly correlated to either eligible, ineligible, or manual. And therefore we conclude that there is room for improvement. But we still need to find out why this is the case. To do so, we open the rule trigger view and select the students. In the rule trigger view, we find first 3 rules which come from a decision table. We see that rule 3, profile 3 and profile 7 are overrepresented and profile 8 is underrepresented. We use our knowledge from the rule set to deduce that this is related to the age. Profile 3 and 7 deal with people below 25, while profile 8 deals with people above this age. So not much of a surprise here. The next 2 rules are a surprise though. The driving under influence rule is almost 10 times more triggered than we should expect when the selection of decision was a random sample. Meaning that students are more often caught for driving under influence than we assumed when we designed this rule set. We also know that drivers who have been caught for driving under influence are marked as high-risk drivers by our decision model. This explains why this rule is overrepresented for the students group. Additionally, we know that high-risk drivers are always marked as ineligible, therefore resulting in a large group of students which is neglected by our decision model. We now have found an opportunity for improvement, because as an analyst we know that business policies state that we should try to make students customers because they tend to stay for a long time. From our analysis we have learned that we tend to neglect students because they have a higher chance to be caught for driving under influence. We can expect though that students will improve their driving habits over time and that we probably, instead of neglecting them, should treat them manually to improve the chance of these currently neglected students to become customers of the company. This concludes our demo of the Decision Exploration Lab.